over is going to be our test review. I'm going to answer the test, the homework kind of towards the end of the today. So this is your Chapter 3 test review. So we've talked about a lot of stuff this year. We're going to try to make sure that we are able to put all of this together. So there's a couple different things that I can ask you on this test, and will be asking you. First type of question will be something like, if I say a function has the zeros, and I say -2, 3, and 6. And I say, write the function in factored form. All right. First off, what do we know that x is going to be the power of in this question? If I tell you these are the only zeros. Okay. How did you know 3? Remember, if I said x is to the 5th power, how many zeros does it have to have? 5. If I say x has 7 zeros, how many x's does, or how many? What does that have to be the power of? 7. How many zeros did I just give you? 3. So what do you know x is going to be the power of? 3. Because there's 3 zeros. 1, 2, and 3, right? 1, 2, and 3. Since there's 3 zeros, we know x is going to be the 3rd power. Since there's zeros, what else do you know about these guys? What ordered pair does that mean has to be? When I say that -2, 3, and 6 are my zeros, I've also told you 3 ordered pairs. They are x-intercepts. These guys are x-intercepts. What does that mean my y is every time? So doesn't that mean it's -2, 0 is an ordered pair? 3, 0 is an ordered pair? And 6, 0 is an ordered pair? We are trying to tie all this stuff together to make sure we really understand it and it makes sense. Are you with me on what I've told you so far? Rich, all this information I'm just kind of covering. I know x is going to be the 3rd power. It's going to be the highest. I didn't tell you any multiplicities. Remember, if I said something like, -2, 3, 6, but 6 has a multiplicity of 2, what would x actually be to the power of? 4. Are you with me on that? I'll show you kind of an example of that in just a minute. Here's what it means in factored form. F of x equals, since it's factored form, I'm going to have my bubbles. You with me? Yeah. Now, what happens when these are my zeros? What is -2 going to do to one of these bubbles down here? But what's it going to do to the entire bubble? It's going to go in as the opposite. But what does -2 specifically do to this front bubble, which I'm going to put it in there? What? It would make it a 0, because if this whole bubble is a 0, this whole bubble right here is a 0. Do I care what happens to these other 2? No. Why? Because 0 times anything is 0. So do I care what this number would be or this number would be? Because what would this 0 do to everything else? And isn't -2 supposed to make the whole thing become a 0? Are you following me? So what would I have to put in this bubble in order for -2 to make it 0? What would have to go in the bubble? An x plus 2. Because if I put -2 in for my x, what does it make the whole bubble become? And once I make one bubble become 0, everything else turns into a, because all it is multiplication behind everything else. Are you with me? Okay, what would be in the other two bubbles? X minus 3. Why do we know that? Because if I plug 3 in, what's 3 minus 3? 0. What happens to everything else? Someone else. What would be my next bubble? X minus 6. Does everybody see how I got that in factored form? That is a good test question. Now, let's change this question up a little bit. I'm going to stay with the same question. But what if they said, instead of write the function in factored form, what if they said, write it more in standard form? Or that I would say something like this, like x to the ax to the nth plus bx to the n minus 1 plus cx to the n minus 2. Meaning, you notice how, what would I have to do to this guy if I was going to get it in this form? How did I take factored form and turn it into standard form when I was in my parabolas last chapter? What did I have to do with factored form? Distribute. What do you think I'm going to have to do in this one? I'm just going to have to get my factored form and distribute it. But now how many times am I going to have to do it? I'm going to have to distribute this guy and this guy, then I get my answer, and I'm going to have to distribute it to this guy, which we need practice on. That is not going away. Yes, ma'am? Absolutely. Because the only way that you're going to be able to take this from here is if you know your zeros, you're going to be able to make this equation. Then from this equation, you're going to have to turn it into standard, and you're going to have to distribute out. So absolutely, yes. If they tell you this, the only thing you're going to be able to make first is your factor form. Real quick and real easy, right? That wasn't that difficult. But then you're going to have to take this guy, which is going to take some time. There's definitely some potential to make errors. But it's not algebra 2 errors, which is what I keep trying to tell you guys. This is the algebra 2. Taking these zeros and understanding that's what they make. Are you following me? That's the algebra 2. The next step that I'm about to do, which is multiplying everything out, distributing, combining like terms, that is not algebra 2. But we definitely need practice on it. Big time. Sarah? No. Watch. Watch how we're going to do it. We're going to multiply this guy right here times this guy right here first. And we're going to leave him alone. So we're going to distribute this, simplify it. Combine all the like terms. Make sure I have done this fully out, combine everything I can. Then after I get that answer, I'll multiply it by this guy last. Okay? Same thing if there was a 2 out here. If there was a 2 like right here, okay, I would multiply this times this, combine all my stuff, and then distribute the 2. I would not take this 2 and give this to this. That's wrong. No. Are you with me? Okay? Just like if I had 2 times 3 times 6. I can go 2 times 3, right? I don't go 2 times 3 and 2 times 6. No. But that's what I saw a lot on the test. I saw you guys distributing everything, everywhere. No kind of, no rules. It was just, you know what? He drew a lot of those little rainbow things. So I saw rainbows everywhere. And we got to fix that. We got to know how to handle these guys. So here we go. Let's take it and put it into standard form. Hold off on this guy. Just save him. x times x is x times a negative 3 is a, done with this. 2 times x is 2 times 3 is a. Now, have I combined everything that I can combine in this one right here? Notice what I'm leaving right here. Leaving that guy right there. I can combine these guys right here. Those are like terms. Are you with me, Sarah? What happens when I have this? What do I get my answer of? It is a negative x. There's a lot of people who are making silly mistakes on this. Think of it as money. If you owe $3, you paid $2 back, you still owe that person $1. Minus 6. Notice I put parentheses back in on this one. I could have kept them here too. That would be fine. And then I'm going to do x minus 6. Now, everything from this bubble has to multiply by everything over here. So how many things is this going to be multiplied by? 2. How many things is this going to be multiplied by? How many things is this going to be multiplied by? Are you following me? Everybody with me? X squared times x is x to the third. X squared times a negative 6 is a negative 6x squared. Done with this guy. Different color to maybe help this out. Negative x times a positive x is a negative x squared. I'm not adding, I'm multiplying. Not adding, multiplying. Negative x times a negative 6 is a positive 6x. Done with this guy. This times this is a negative 6x. This times this is a positive 36. Now, do you see how this guy and this guy have an x squared? They can combine, they're like terms. You see how this guy and this guy, they are like terms, so they can combine. But I have to be able to, now, am I multiplying anymore? No, what am I doing? Adding and subtracting. They have different rules when I add and subtract or when I multiply and divide. Gotta know those rules. I'm telling you, that's where I'm finding a ton of my mistakes. So what happens? Does this guy combine with anything? X to the third. Everybody with me? If I owe 6 and I borrow one more, what do I owe now? Negative 7x squared. If I have $6 and I need to pay $6 or I owe $6, how much do I have? There it is, kind of in standard form. Does everybody understand that? If I want to practice this tonight for homework or for my test, what can I do to this problem to practice this? All you have to do is do what? Change the zeros. All you have to do is change those numbers and you can make up a new problem. All right. Here we go. Draw, sketch of a graph with the zeros five, 2, and 4. With positive a value. Actually, let me go back to one for just a second. Go back to this type of problem. So, I'm not going to go through everything about this, but let's say they said something like this. Let's say they had zeros like this. So I'm still on this type of problem. Are you with me? The first problem I did. What if they said the zeros are -6, -4, 3 with multiplicity of 2. Tell me some stuff that you know. What is x going to be to the power of in this question? What was x? 4. So it's going to be x to the 4th power would be this question. Are you following me? Now, how would I make my function? How would I make my zeros? It'd be f at x equals, what would be my first bubble? X plus 6. Next bubble will be x. Nope. That would be wrong. Get me the wrong answer. It's got to be a +4. Remember, this has to plug in to make it 0. Okay? What would be my next one? X. Now, here's where that multiplicity of 2 comes in. Do you see how it's telling you this bubble should happen twice? How can I make this bubble happen twice? What can I write on there? Where? That's the only difference, guys. Now, I'm probably not going to ask you to do this one foiled out because it would just take too long for us. But if I was just foiling it out, doesn't this just mean x plus 6, x plus 4, x minus 3, and another x minus 3? If I was doing this problem, guess what I can do? This times this, and do what with these two guys? No, they do not cancel out. Absolutely not. What can I do with these two guys back here? Leave them alone. What did I do up here? What did I tell you to do with this guy? Leave it alone. How many bubbles can you deal with at once? So why are you trying to deal with 4? We've already seen that we make mistakes in this. Let's simplify this process. Multiply this bubble times this bubble. So when I say this bubble right here times this bubble, leave these guys alone. You with me? Simplify it. You're going to get some bubble here, and then you're going to get x minus 3, and then x minus 3. What am I going to do here? I'm going to multiply this bubble times this bubble. What am I going to do with this guy? Leave it alone. And yes, you're going to have to combine like terms and distribute and a bunch of stuff. You were supposed to be able to multiply 5x squared times 4x. You're supposed to be able to do that. Combine like terms. You're supposed to be able to do that. You can only combine things like, can x squared combine with x's if you're adding them? No. Can I multiply x squared times x? Yes. Do you see that this is a total different problem? Can you simplify this even further? Can you simplify that even further? Yes, you can. This becomes 6x to the 3rd. Can you do this any further? No. You've got to know the difference between these rules. That's not algebra 2. This right here is not algebra 2. That's algebra 1. Yes, ma'am. Okay. Yep. The one that has the multiplicity of 2, notice the only thing that happened is it became square. You're just saying that that bubble happens twice. That's it. All right? All right. So if I was asked to draw a sketch of a graph with these zeros, okay, what did I tell you about these guys right here? -5, comma, what's the ordered pair? 0. What's the ordered pair? 2, comma, 0. What's the ordered pair? 4, comma, 0. That's what it tells you. If it tells you there's zeros, it's saying that this guy is where it hits the x-intercept. That's what we've talked about, all these 2 chapters. Can I plot these on a graph real quick? Sure. 1, 2, 3, 4, 5. Boom. 1, 2. Boom. 1, 2, 3, 4. 1, 2, 3, 4. Boom. So everybody see those 3 points up there? In fact, do them in a different color so we see them. 1, 2, 3. Now, if I know my A has a positive value, okay, what do I know that this x is going to be the power of? How do I know that it's going to be x to the power of 3? Because there's 3 zeros. Do you know that I have a positive A? Didn't I give you a chart that says if you know your A is positive and it's an odd power, don't you know you're in behavior? Do you remember that chart that I gave you? Well, you're going to need to use that chart because I know that this is a positive A with an odd power. I know that it's going to start down, and I know it has to end what? You see how those are the 2 ends? Now, do you see how I said just sketch the graph of this? See how it says just sketch it? I'm not trying to ask for a perfect graph here. I'm just asking for a quick sketch. It means really quickly draw it as fast as you can. Notice, what did I grab real quick? What was the first thing I grabbed? The zeros, right? Next thing, what did I look at? In behavior. Have I taught you in behavior and how to look at it? Better believe it. Now you're going to use it. So here we go. I know that it starts down. I know it's going to come up to this. What does it eventually have to do? Has to turn and go back through right here. You with me? And what does it have to do again? Turn and go back up. And boom, that's all you would have to do is just draw a quick sketch. Do I care how high or low these things go right now? No. See how smart we are. What would this be called and what would this be called? Relative maximum and relative minimums. Am I asking about those in this question though? No. All I asked you was just draw a quick sketch of what this thing would look like based on your in behavior and your zeros. You know it should look something like this. We're not drawing a perfect graph. We're just drawing a quick sketch. Does everybody understand that? Now, what if I gave you something like this? If I said the zeros, so same questions, are -5 to a multiplicity of 2. A is negative. -5. 1, 2, 3, 4, 5. That's going to be a 0. What else is a 0? Well, what happened at 2? So how does that look like on a graph? Well, I've showed you graphs where this happened. First off, I graphed my x-intercepts. Are you with me? Now I need to look at my A as what? But what is my x to the power of in this one? It is not x's to the second power. How many zeros are there? 2, but this one has a multiplicity of 2. So what does it actually count for? That actually counts for 2 of them, and there's another one, so x is going to be to the third power still. What is this? Odd. My A is what? Negative. My end behavior should be down, and then should end up. Now, whoops. Should be up, then down. You with me? Now, here's the thing. If I try to draw this, this is going to be the wrong way. If I try to draw this like I did my last one, and I go like that, and I do this, what happened here? It ended up, because can this thing go back down through there? Why? There's no other what? There's no other x-intercept. I gave you all the x-intercepts. So how the heck could this thing go down, then come back up, but then end down without going over the x-axis again? I think you're trying to say the right thing. Do you remember our cases where we had this? It would go down, come back up, and once it hit this, what does it do right away? Remember me talking about how it just touches it like that? Because my end behavior has to be exactly what we've talked about. Is this all kind of tying it together? All right. Let's go over the homework real quick, and then after I do the homework, I'm going to go through some skills with you that you can practice for tonight. Determine the number of relative extrema. So this is talking about relative. How many relative extrema does this have? Well, if I look, that's relative, that's relative, that's relative, and that's relative. So that thing should have, you should have put 4 there. How many absolutes did this guy have? This thing had 0 absolutes, because if I look, does this thing ever stop going to negative infinity? No. No. So can I find the lowest number ever? Nope. Does this thing ever stop going up? So can I ever find a highest? No, it cannot. So there are 0 extrema. State the intervals where the graph is increasing. So this is where you're talking about your x. Do you see from here, from negative infinity, when I'm talking about my y, or my x value? So do you see from this way all the way to about right here that graph is going up? So that would be from negative infinity all the way to about negative 2.5. You see what I'm talking about? It's increasing. What happens from 2.5, which I'm on my x, from 2.5 to about 1? What happens to that graph? It starts doing what? Decreasing. Would I be putting that in my answer for this problem? Because what's it asking me? Intervals, right? Between what and what? Now, from 1 to about 1/2, what does this thing do? From negative 1 to about 1/2, that thing is going up again. From 1/2 to about 2.5, what does this thing start doing again? And then from 2.5 to infinity, that thing increases again. So all you're talking about is where you're going up on your graph, and you're not talking about where you're going down. So do you see, if I colored these, do you see from here to here, what's it doing? Going up. From here to here, what's it doing? From here to here, it's doing what? So if you look at all these bubbles, I described what my x was when it was going up. My x was negative infinity over here, all the way until it got to about negative 2.5. And then it stopped. It went down. So my interval stopped. Then from negative 1 all the way to 1/2, it was increasing again. That's all it's asking you, is what's your x's when your y is going up. Yes. Negative 2.5. All right. First off, I like to go to, is it even or odd? Is this function even or odd? This function is not odd. It is even. How do I know? Starts down, ends down. The only type that can start the same way and ends are evens. You with me? Okay? What is the a value of this function? My A value is negative. How do I know? Because it started down and ended down. That has to be A value negative. Can this function be a 6-degree polynomial function? How do I know whether it can be 6 degrees or not? How many extrema is a 6 degree allowed to have? 5, 3, and then 1. Exactly right. How many extrema does this have? 1, 2, 3, 4, 5. Could this be a 6-degree polynomial? Yes. And the reason is because it has 5 extrema. Whatever. You following me? This is all from the lesson on Friday. State the domain. The domain is everything that what can be? X. Is there anything that X can't be? So it's from negative infinity all the way to positive infinity. Remember, that is left and right. Does this graph ever stop going left? Does this thing ever stop going right? No. X is only left and right. What is the range? What is the range? Hello? What does the range have to do with? My Y value. Does this thing ever stop going down? No. Does it ever stop going up? Right there. We'll call that about 2.5. If I give you a question on this, it won't be one of the ones where it's in the middle of something. I don't know why they do that. So where does this thing start at for my Y's? Negative what? Negative infinity. And what's the highest value it goes to? And what would I do? Why did I put a bracket there? Because it's allowed to be 2.5. It's allowed. It includes 2.5. How many relatives does this thing have? It has relative. That's a relative. That's a relative. That's a relative. That's a relative. How many relatives? 4. What is this one right here? Absolute. This one right here is an absolute, and it's an absolute maximum, because that's the absolute highest this thing reaches. So 1 absolute. You need to go through this skills book, and it is up on Portal. You can look at all these different things if you are getting ready for your test today. I would go through the odds of sections 3.1, 3.2, 3.3, and 3.4. You should be able to do all those different for extra practice tonight before you test. 1, 2, 3, and 4. Chapter 3. It should be in Portal. That's that PDF file I attached. For homework.